Now, the major advantage with the frame relay is it's going to be a little bit cost effective solution when you compare with lease lines. So let's see how the frame relay is going to work first. Now, frame relay is going to use the existing service point network for providing the lease line connections. WAN connections. Now, take an example. Now, I have a location here, the router 1, which is supposed to communicate with router 2 and router 3 and router 4. And I want to provide connectivity between these 4 different branch offices. Now, to provide a connectivity between these 4 different branch offices, what we are going to do is we are going to use the pre-existing service point network. Now, we call this as frame relay cloud because they have some pre-configured devices here. Now, these devices we call them as FR switches, frame relay switches. Probably they are routers only, but they are doing a job of a frame relay switch. Okay, so we'll get into that more in detail. Now, we call this as frame relay cloud. And what service port is going to do is service port is going to allow you to connect to the nearest router to the nearest possible frame relay switch, connecting your router to the nearest possible frame relay switch, just like connecting to the nearest exchange office, connecting to the nearest possible switch, and then he's going to allow you to send his information, customer information over his private network. And then he's going to reserve some amount of bandwidth for your traffic, and he's going to charge for that. Now, the service provider will have a pre-existing network which is built for sending the information. So more similar to lease line as well. Lease line also is more similar to that, but the difference is now in the lease lines, service provider will provide a separate line for the customer, even though they might be going on the same fiber cables. But here it's not like that. Okay, so another major advantage we get with the frame relay is it is going to be the cost effective solution when you compare with the lease lines. Now, let's try to understand what's the difference between how the frame relay is going to differ when you compare with the lease line connections. Now, if you talk about lease line connections, let's say I got a router 1 trying to establish a connection between router 2, 3, 4. Now, in case of lease line connections, we need to have 3 separate dedicated lines given by the provider. Okay, so probably different locations, and also we are going to use some 3 different interfaces. Now, each and every interface, because we cannot have the same 2 different connections on the same interface. You must have some 2 different interfaces and 2 different connections. So in fact, I got 3 interfaces, 3 different connections, 3 different interfaces. But using the frame relay, what I can do is I can connect. Now, we call this a frame relay cloud. Frame relay cloud is nothing but the service provider network. Okay, so now in this scenario, what we are going to do is we are going to connect our router nearest possible frame relay switch or the frame relay device or the modem, again back to the frame relay device. And then on the same link, I can have 3 separate virtual connections. I can build 3 different connections on this, and we call this as point to multi-point connections. We can have something called one point can have 3 different connections virtually. Virtually, we can have 3 different connections. So it's going to reduce the number of interfaces required, and also it's going to reduce the cost wise because the service provider is using the existing infrastructure to send your data over the WAN. It makes somewhat scalable better than lease lines, and also it's going to simplify somewhat management also easier when you compare with lease lines. Now, nowadays we have some better solutions as well, like MPLS or VPNs kind of things. But when you compare with lease lines, it's going to provide you the better option. Now this MPLS technology is more similar to your switching kind of stuff. If you just talk about a normal switching technology, let's say I got some device, 4 computers, and I want to connect these 4 computers in the LAN. Probably one option is I can just have a separate connection here, separate connection here, separate connection here. Now in this way, I need to have 3 separate interfaces on the one of the computer. So instead, what I'll do is I'll try to connect these devices to the centralized switch, centralized switch, centralized switch, and the centralized switch, and that's how we do the LAN connection. So they all look as if they are directly connected. So in fact, they can talk to each other. Now the same kind of thing we are going to do here also. We have a router, and that particular router a head office trying to communicate with some multiple branch offices. We are going to connect to the existing frame relay cloud or the frame relay network, connecting to the nearest possible device, and nearest possible device, and then like that. Now this frame relay cloud or the frame relay network, service provider network, is doing the same job of a switch, which provides a centralized connection to multiple sites. Now there are some similarities here as well. Let's try to get into some of the other things. Now here technically there is something called virtual circuit we need to understand. Virtual circuit is a logical connection which is built from one end to another end. Now from this point to this point we got a virtual connection, and from this point to this point we have a virtual connection here, and then we have a virtual connection here. Now this connection from one end to another end, we call it as virtual circuit. It's a connection inside the frame relay provided by virtual circuits. Now why we call as virtual circuits? Because if we take an example here, this diagram, in this diagram there is a connection from this router to this router, this frame relay switch here, and then in fact there is a connection from here to here, but it's a virtual connection. There is no permanent physical connection or a separate line given by the provider. Now once the traffic enters from the customer side, it may go from this route, depends upon the service provider network, or it may be going from this route, or it may be going from this way. It's going from this, and then here probably you have some connection here, maybe going like this. Now there is no permanent path or a single path between one end to another end of the service provider. Now that's the reason we call there is a virtually these two devices are connected, these two ends are connected, and this connection we call it as a virtual circuit. Now these virtual circuits are something created by the service provider. So there is a virtual circuit from here to here, there is some virtual circuit from here to here, and then there is a virtual circuit from here to here. If you want, you can also build a separate virtual circuit from here to here as well. So it's more like, you have a separate connection like this. It's more similar to that one, but the only difference is you don't have a direct connection. You go through the network, the same existing network, and you can have a separate virtual link connection, where if you take a lease line connection, you need to have a separate dedicated line to be given. But in this scenario, it's going through the frame relay cloud, and then you just need to build one virtual circuit from here to here. Probably service provider will charge for that, but it's not going to be very much expensive as lease line connections. So you just need to add some virtual circuit between here to here, and then if you want one more virtual circuit from here to here, you can also do that. So the logical connection which is built between one end to another end, we call that as virtual circuits, and these virtual circuits are identified with some DLCI numbers, data link connection identifier numbers. Now these numbers will be in the range of 16 to 1007 given by the service provider. Now these DLCI values are more similar to the MAC address of your device. So if I just take an example, I have some device 10.001, and then 10.002, 10.003, and 10.004. Now we can assign the same network for all these devices because they are in the same LAN. Similar way, here also I can assign the same network IPs, as they are logically in the same. It's more like they are logically point-to-point networks only. We got one point-to-point connection from here to here. We got a virtual point-to-point connection from here to here. We can have virtual connection from here to here. We can still have one more connection from here to here as well if you want, through the virtual circuit. So which means all the locations can have the same network, can be used, unlike lease line connections, because in case of lease line connections, if you're connecting 3 different lines, we cannot use the same network all the interfaces, because every interface of the router should be in different networks, and that is something you need to use /30 subnet mask on every point-to-point connections. But here it's not like that. Now there is one more major difference is whenever you are trying to send a request from 10.001, and I'm sending a request to 10.001 to 10.002, so the request goes to the switch, and the switch do not understand the IP address, right? Now there is a protocol called ARP which is going to convert the IP address. It's going to resolve the MAC address of the 10.002, and the request reaches the switch and with the source and destination MACs. because the actual forwarding on the switches will not happen based on the IP addresses. Now the same kind of thing happens here as well in case of frame relay also. In case of frame relay, every virtual circuit will have one number given by the service provider, and we call that number as DLCI number, DLC value or data link connection identifier values. Now let's take an example. The DLC value of this connection is given and it is locally significant value again, and let's say the DLC value on this side is 103, and let's assume that the DLC value on this connection is 104, which is going to router 4. And then the connection from router 2 to router 1 is given a DLC value of 201, and the router 3 to 1 again given a DLC value of 301, and the connection from 4 to 1 is given as 401. Now whenever you are sending any packet, let's say the packet comes from the router 1, it comes as a normal IP packet, and once it enters the service provider network, it will not go based on the IP address. So which means inside the service provider, the packets are forwarded based on the DLC values, and there is a mapping done by the router here. It's going to map the local DLC value with a remote IP address. So which means if any user want to go to 10.002, there is a mapping done with the DLC value of 102. So which means if any user want to go to 10.002 here, he should go with this DLC value. Now enters the service provider with this DLC value, and then there is a mapping done by the service provider that anything coming from 102 should go to 201, which means based on the DLC values it will be forwarded just like MAC addresses in case of switching, and then it will go as a normal IP packet when it goes outside here. So the actual forwarding inside the frame relay switch is not happening based on the IP addresses, it's actually happening based on the DLC values. And these DLC values are used for mapping for a local DLC value. The local DLC value 103 is mapped to a remote IP address. So which means if any user want to go to 10.003, he go with this DLC value, and then from there it reaches route 301 and then come back. It's not compulsory that it should be reverse number, but I just use a reverse number just to make it a simplified way to understand. And then we can use a 104. We can simply say 10.004 mapping with 10.004. Okay, so the local DLC value mapped with the remote IP address. Now similar way the same thing happens on the router 2 and router 3 and router 4 as well. Now these mappings, either it can be done manually by the administrator on the routers, or it can also happen automatically by using a protocol called inverse ARP. Now in the frame relay there is a protocol called inverse ARP which will automatically map the local DLC value with the remote IP addresses. Now this is something taken care by the service provider, or if you are doing some big complex network implementations, you can also do those mapping configurations on your local routers. Okay, so probably we don't do anything on the local router much. We rely on the inverse ARP to do the automatic mapping of the local DLC with the remote IP addresses. So as I said, you can simply compare the same thing with the LAN, where your packet comes from as an IP packet. Once it enters the switch, it will be forwarded based on the MAC and then back as an IP packet. So which means IP to IP communication happens, and there's a protocol called ARP which will convert your IP to MAC, that is resolving the IP to MAC. Now the same thing happens here. You're communicating based on the IP, but internally inside the switch the forwarding happens, or the virtual circuits are identified with DLC values rather than identifying the actual IP addresses. We'll see some basic implementation here in our scenario, where we'll see some of the basic implementation how it goes later on. Let us try to finish off the remaining things we have. Now there is one more thing. Frame relay works with something called shared bandwidth. So let's take an example. I have a head office, and in that head office I got 3 different branch offices here, and I got some virtual circuit here. There is a virtual circuit going from here and then connecting to here. Now we represent them as a dotted lines because there is no dedicated permanent WAN connection between them. Now let's take an example. This is my head office which is connecting to the branch offices here. This is my branch office here, and this branch office and this branch office, and probably in each and every branch office, let's say I'm using 3 Mbps link on the head office, and this head office is actually connecting to three different sites, that is my branch offices, and each and every site will be getting a 1 Mbps of link. So which means this 3 Mbps link will be shared between all the 3 links, and the service provider will assure that there is a 3 Mbps guaranteed bandwidth on that particular link, and that is what we call as CIR, committed information rate. Now CIR is the actual amount of bandwidth committed by the service provider, committed information rate. This is something we use in case of frame rate terminology. Now what if any one of the link is not actually transferring any information? Now there are some cases where one of the link is not forwarding any traffic because there is no active traffic going on this link, and maybe the remaining 2 links are still sending the traffic. Now in this kind of scenarios, these links might get excess of the bandwidth, somewhere around 1.2, 1.3, something like that. Not exactly 1.5, half of, but a somewhat extra bandwidth it gets because there is a sharing of the bandwidth, and this is happening only between the same customer sites. And don't expect the things can happen between different customers. It happens based on same customer, where you have a one line connecting to 3 different branch offices. Now we call this as hub and spoke terminology, hub and spoke topology, where you have a centralized head office connecting to 3 different branch offices, or we can also call as point to multi-point implementations. Now that's how it works with a shared bandwidth concept. And then there is one more thing we need to know, something called LMI, local management interface. Now this LMI is the actual keep alarm mechanism between the router and the frameless switch. Now keep alarm mechanism is something like, let's take an example. I have a switch which is connecting to the PC. Now what if there is some issue with the cable, or maybe the issue with the switch? Now probably you'll see the message here as local area unplugged, right? So you'll just see some messages called local area unplugged because by default there is something called keep alive mechanism happening between these two, and the default keep alive is 10 seconds. It will be same thing between switch and router to router, like that. Now this is what we call as keep alive mechanism. So for every 10 seconds they keep on sending keep alarm messages. Are you there? If I don't receive that keep alarm messages, in that case it's going to simply put the port into down state. The same thing happens on the router interfaces. When we use show IP interface brief, your interface will be shown as down. But in this scenario we don't have keep alive between router to router. We have a keep alive between our router to a frameless switch. Now this is my router and the frameless switch. They exchange some messages between them, and those messages we call them as LMI signaling, local management interface. Now this is a signaling mechanism between a router and the frameless switch to see the status of these 2 interfaces or the 2 devices. If something goes wrong on any one of this side, it will automatically make the interface down. Now there are 3 different mechanisms or LMI standards which can be used. We have something called a Cisco LMI, which is default on Cisco, and it can be ANSI, and there is something called Q933.A. Now which LMI to use, it all depends on the device. So the router will send a request when it establishes a connection. It will ask which LMI should I use. Now the frameless switch is going to respond with some LMI. Let's say if it responds with some ANSI LMI, the router will automatically adjust with ANSI LMI, ANSI method, that is what ANSI. Now this is what we call as LMI auto sense, where the device will automatically adjust the same LMI on the router based on the service provider frameless switch. Now if you want, we can manually change these LMI types, but that's something we really no need to do that. So LMI can be auto sense. On Cisco routers, LMI is auto sense and there is no need to configure it. But if you want, we can still use manual LMI commands. Now the last thing, there are few network type implementations. Frame relay can be configured into multiple network types. We can have just one router connecting through the frameless switch and then we can have something called one-to-one connection, that is point-to-point connections, or we can have one site connecting to multiple branch offices, and we call this as point-to-multi-point connections. So probably at the CCNA level, it is something not really required for you to get into different frame relay implementations. But here in the basic labs, what we do is we'll go with some basic frame relay point-to-point configurations generally, just for testing purpose. We'll go with a basic frame relay point-to-point connection. In that, we'll be seeing some of the basic configurations, what are the configurations we need to do on the customer side, and what configurations goes on the service provider side. So that's something we'll be seeing that in our next video, where we'll see the configuration of the basic point-to-point implementations, and then verification commands and some testing commands as well.